Hello everyone, my name is Kevin Ramirez Martinez, and I'm a member of the Analog and Digital Programmable and Reconfigurable Rapid Prototyping Integrated Circuit. And my team members are
Rose Sánchez Irizarry,
Juan Rivera Santiago,
Kevin Montalvo Vega,
Jose Quiñones,
and this is our project.
Throughout this presentation, we are first going to discuss some of the objectives that we set for ourselves, as well as the timeline defined for this project. The metrics that we decided were essential for the success of this project as well. Discuss the problem as well as the approach that we selected to tackling it. And finally, we're going to go over some of the progress that we have achieved.
The objectives for this project are: learn coding tools like Virtuoso, Spectral Simulation, Layout Excel, and CIF Generator. Design CMOS digital building blocks on Virtuoso with external connections. Design analog blocks with external connections in Virtuoso. Design analog and digital building blocks that can be reconfigured using pass transistors. And compare functionality of program gates and externally connected ones using Spectre.
This timeline shows the projected timeframes for each of the deliverables throughout the lifespan of this project, and it includes the current phase we are in. As shown, we are currently in sync with the planned schedule. The metrics for success for this project are as follows. The configuration in digital circuits does not affect the function and minimally affects the propagation delay when compared with external wiring. The configuration of analog devices allows for changes in polarization schemes on current mirrors and programming gain on differential amplifiers.
Some studies have shown a lack of understanding on some undergraduate students on how their testing environments affects their design. This is due to a lack of experimental experience to accompany the theory, which is highly focused on simulations as of late. That is the reason why the problem that we are tackling with this project is that of creating a programmable hardware tool which provides exposure to combinatorial digital circuits and facilitates the development of laboratory skills and fast prototyping in the design process for introductory courses.
To have rapid experimental prototyping, students will design gates that can be configured into simple analog circuits in an integrated fashion and can be externally configured. These gates will be simulated and compared. The configuration should allow for 3 different types of current mirrors and 2 differential pair. This section should design transistors in a parallel and series configuration, add pass transistors for possible gate connections that need to be shorted, design current mirrors using transistors to mimic diode connections, and design PMOS and NMOS differential pair allowing a connection on source and drain to current mirrors.
In normal data logic classes, it is taught that you can build any type of logic circuit using NAND or NOR gates. So, taking them as a base, we converted them to a transistor equivalent.
A test circuit implementing pass transistors was built in order to test the design and connections of the NOR/NAND gate. By creating said prototype, we were able to replicate which type of circuit was being chosen, depending on the signal received.
Simulating the prototype circuit for a period of time and sending at the midway point a programming signal to the pass transistors, we were able to change the prototype circuit from a NOR gate to a NAND gate. As we can see in the graph, we're sending input A and input B, while input B is the most significant bit. During the first half of the graph, we can see the output act as a NOR gate, and after the midway point, it starts acting like a NAND gate.